there were a couple of questions on the linting process in the last session I saw, and then I thought let me answer this in this session. Okay, what is lint? Okay, that's a good question. Basically, linting is a process, a step which is used in the ASIC design process, ASIC design process in order to check how good your Verilog code is. Good means what, right? It is not, it should look beautiful. It is that how well it is written for the hardware implementation, right? How well it is written. So very first thing is it should be synthesizable. It should be synthesizable. So synthesis, already now what is synthesis, right? So it should be, if the Verilog code we should be able to convert into gates. That is the very first thing. It should not have unsynthesizable or non-synthesizable constructs, like timing related, some hash delays, right? So there are a lot of constructs which are not synthesizable. Those should not be there. For example, while loop, right? So non-synthesizable construct should not be there. So now, and I'll talk about the tools later. So let me go over what are the checks it does. That and unintentional latches. For example, now the basic electronics, and when you are talking about latch versus flip flop, right? You, by the way how you are writing code, right? Unintentionally, you are not intending to implement a latch, but by the mere way how you code, it will intend it will be translated into a latch. Okay, so usually we say latches are not good for the design unless it's a memory element. Okay, and the other this thing is unused declaration. What is unused declaration here? Unused declaration, for example, now in your Verilog code, you will write module and ports, and then you will declare some reg wires, but you don't use them anywhere in your design. Okay, so finally they may be implemented as some hanging wires, right? So which are not connected anywhere. Those are bad. Now driven and undriven signals. At the same time, now you have declared and you are not driving those signals throughout the program. And race conditions. Race conditions means, for example, now you have one always block here and another always block here. Let us say one flip flop output Q you are assigning here to D, and the same this Q in this always block also, right? You are assigning. Basically, what is happening, right? It is it may be even some other it may be some D1, right? So both you are trying to assign to Q, it causes a race or multiple driver problem. Okay, and your linting tool, right, when you're parsing, it will check for all these. Okay, one target, that is left hand side signal, whether it is been assigned in multiple blocks, because this always block and this always block both executes concurrently. Within always block, it is procedural. Okay, incomplete assignments in subroutines. Okay, so in the subroutines you are not assigning the properly. In, for example, now say you are declaring 10 bit and then only 2 bits you are driving, something like that. Case statement style issues. Okay, so the case statement when you're using, is it case X or case Z or parallel case, full case? Synthesis, you, I think we will talk about it specifically parallel case and then full case directive. Okay, and set and reset conflicts. Okay, so you have, okay, so set and reset conflicts. For example, now the same kind of thing you're setting in one and the resetting in the other block, and also right timing, right? And out of range indexing. For example, now you have declared 8-bit and then you are trying to assign a 32-bit value, right? incorrect usage of blocking and non-blocking assignments. So we saw the list of codes where the blocking assignment and the non-blocking assignments, how the circuit will be translated into. So all these things, right? These are some of the examples. Okay, there may be list of another big list. Okay, now what we are trying to say, all these rules you are embedding in a tool, okay, embedding in set of tool, that is linting tools, and then you are running the tool set of guidelines for your RTL. So before you take it for the synthesis, you do the you have a quick check of all these things. Now if you look at the lint summary, right, those kind of things, in case if there are any, see, unconnected logic driven clocks and sequential data pins driven by a clock, right, all these, right, will be see here, sequential data pins driven by a clock, right, sequential clock pins with multiple clock waveforms. All these are rules which you have set, and then this rule deck you're giving to a tool, and then the tool is checking for all these rules. So that is what the linting is used for. So this is how the report it generates. Now spyglass is one such tool, and there are other tools as well, basically to check the hygiene or how well the Verilog code is written. And because these we should not end up you synthesize and then coming to know that some things you have found, these kind of things, right? All these will be checked in the linting process. Okay, so because it is there now, synthesis tool also can do the basic linting process, and that is how now we run a command in order to generate the linting report here. Okay, so whether it is incomplete assignments, whether it is in subroutines or in the main program, it is one and the same. Don't bother too much about the subroutine word there. Okay, so this is the brief about the linting. It is not in the main flow of this one. Before you start the synthesis, you run the lint, make sure these kind of issues are not there with the code, so that in the later cycle you are not finding these issues. That is the objective of linting. So any other questions so far on the topic that is about linting?
Yeah, am I good? Hello.
Yes.
Yeah, in last session, we checked in the synthesis.
Now can you just post your question? It is easy for me to answer because your voice is breaking. Just post it in the chat box.
Yeah, sure.
Shravanti, are you able to connect now?
That file and I'll show you like each and every command. So the first command is like we are setting the design name. That means the top module name of your RTL code. So according to my design, I have selected a UART design. So my top module name in the RTL file is this name. So I am just giving my design name. I'm setting my design name to that particular RTL name. Okay. If we have our own. Okay. So I'll go to that SDC file. Once let me complete the explanation of the stickle file. Okay. Now, next command is read underscore libs and the path of the file where your library file is. Now, in your allocation of PCs or allocation of every like slots, like there might be confusion like which path you need to give. So here you can just go to that particular directory. Now, I'm just going to that particular directory. I know because this path will be same for all the access whatever you're getting, you will have a home directory. Inside that, you will have a cat directory. So that path you want to know means there are some few Linux commands so that you can just give that path. So inside the computer, you have a file system. So inside home, you have a cat directory, and inside that you have foundry. Inside that you have digital, 45 nanometer. As I told you, inside that you have libs. Inside that you have lib. Here you can select max or min. So here, if you want to know the path, like you can't manually type your path, right? So if you want to know the path of that particular library file which I am going to read, just open the terminal here where the file is and give pwd. This is one of the Linux command where you can know the present working directory path. So you can just copy paste that path and you can just paste it in your run.tcl. Just give pwd. Pwd is present working directory. That means present working folder in Linux. So I'm just giving PWD. It is showing me a path. You can just click on that and just give copy, and you can paste that respective path in the run.tcl file. So I'm just clicking paste. So that paths get pasted here. So this is how you have to get to know the path of your files according to your PC that access is given to you. So these are some basic commands of Linux. So if you give pwd in the terminal wherever that particular file is, you can get to know the path of that particular file. So I hope it is clear till here, opening the document and saving the paths, writing out the paths. Okay, so once we read the library, we set the design name. Next, we are entering into reading the RTL file. So read HDL is the command for reading my RTL file. So whatever the design may be, if you can run your own design, you have to save that file with the extension of .v, and you can just give the path of the file where it is, and you can just give a command read HDL and read that particular file. Okay. Next is elaborate dollar design. Now, if you see, if in the C language also, you set some variable to some value or some number. So here I have set design to the top module name. Now, I want to elaborate my top module. So what is elaborate doing here is it is linking my logic or the functionality of my RTL code to the input and output ports in the RTL design. So it is nothing but it is elaborating my design, and it is linking the logic to each and every input and output ports present in my design. So the command is elaborate and dollar design. Because I have used dollar I mean to say design for my RTL top module name, I am using the same variable or same name to elaborate also. So I have set my design using this variable. That's the reason I am calling that variable again back with a symbol called dollar. So elaborate dollar design resembles I am elaborating my top module. Now, next command is check design unresolved. So if there are any submodules, as of now I don't have any submodules in my design. So if there are any submodule RTL files separately other than the top module, while reading the HDL, I forgot to read the all HDL files. So if in such cases, if I'm not reading any submodule RTL files, that means I am I'm not linking one of the submodule to the top module. So in such cases, it will show such kind of errors when you execute a command check design unresolved. So if there are any references or any submodules that you did not link to your top module RTL, that particular errors will be displayed when you give a command called check underscore design hyphen unresolved. Okay, what is the difference between setting the design and read HDL? Yes. So set to design, we are giving the just a top module name. We are not giving any .v extension. In HDL file, we are telling to read the complete RTL file. We are just setting the top module name. This particular command is helpful when you have multiple instantiations or multiple submodule instantiations in your file. So you guys are taking your own designs to complete the works, right? So I just wanted to share this command set design. You have to set the top module name not with .v extension. While reading the HDL, you have to give the extension also as .v. Next is you are reading the SDC file. So in the same way, where is the SDC file? You can just give present working directory and you can just copy paste that particular path in the read SDC command where your SDC file is. Now let us see like what is there in that particular SDC file. So I have a directory called SDC. In that I have some SDC file. Now here in the previous session also, I discussed the cell delay values will be taken from the library file. Now, what about the port delay values? There should be some delay values for the ports. Those are nothing but my input ports, output ports, and the input output ports if any. So as of now in my design I have two clocks. So I need to give the clock frequency for that particular clocks to propagate into a sequential cells. So here the command to give the clock is create underscore clock. So how you will get to know the command, I will show when I execute the things. So create clock is a command to give the frequency. Now you need to give some delay values to the ports. For cell delays, it will be taking from the library, but for the port objects, as a user, you need to give the port delay values. Now set input delay and set output delay are the delay values that you are giving to your input and output ports in the RTL file. So I am just mentioning all inputs and all outputs because I don't know the number of inputs. For all the inputs, it's easier for me to declare all inputs and all outputs because there are so many number of inputs and outputs. While writing out the output SDC, while writing out the output SDC file, it will be assigning to each and every input and output port. I'll address your questions one by one. Okay. Next is set input transition and set load. So as I told you, for a cell, now the delay value of this particular cell is dependent upon input transition and output load according to the theory that we have discussed in the previous session. Now, what about the port delays? So port also have to have some transition. Now here I am defining some transition values and the capacitance values for the input and output ports. Okay, because I am giving input port all the transition, that means it is starting off with this particular transition value and load is the output capacitance for all the output ports. So this is how we are declaring the delay values for the input and output pins and my clock objects. Okay. So there is some question, how did you decide that it's an 83? As according to the UART specification file, for our design, the frequency what we got was 12 megahertz. So the tool is accepting in the nanoseconds form. So 12 megahertz, we have converted it into nanoseconds. So it is nothing but 83 nanoseconds. So now how it is decided is there will be a team again called time budgeting team. So they do multiple iterations for this circuit. So they finalize some frequency which is suitable. It is not a single run where they are defining this frequency. Multiple iterations will be done. first some frequency is taken, then the results are taken. So comparing the results, they will finalize this frequency. So as a new user, you can just start off with some of the frequency randomly, and you can change the frequency and see the changes in timing, power and area once you report the results. So once you run with your design, it is anywhere you can just take some 250 or 500 megahertz for your own designs and you can execute. Okay. Okay, what is the tool that is used for that? No, there is no such tool like where the time budgeting is there. Uh, Here it is a pen and paper process again, according to the previous releases of that integrated circuits or previous releases of that integrated circuit. I mean to say the logic which have been implemented previously, it might be there. Due with that particular analysis, they will just estimate the frequency and do the trail runs, and they will finalize the frequency what is required. Okay, here as of now, here how the time budgeting is done is, now the frequency is 83%, right? Just I have took 40 and 40% for the input delay of amongst the 83 nanosecond, and 40% for my output delay amongst 83 nanosecond. So usually it is taken among 30 to 40 50% of my clock period. So that is how you need to balance input and output delay. This is not again finalized, that is that you need to take only 30% or 40%. That again varies according to the application and according to the RTL you have picked. So for this process, I just took 40% and 40% of my clock period for the input and output delays. Okay, there is a question raised why we are mentioning input and output delays. Okay. Now, if I take an example, my input port is somewhere here and my block is starting from here. So, this input port is not the starting input port of your complete integrated circuit. There might be some other block through which a register is coming. I'm just assuming a circuit, and some combo logic is coming, and that is transversed to your input port. So you are not sure your input port is the starting pin or the starting port of your complete integrated circuit. It is parallelly coming from the previous module or previous interfacing module of your complete integrated circuit. So that is again propagating with some other clock. That's the reason we need to give the input and output delays with respect to clock. I think I have answered your question. Okay, so I'll show you my RTL so that you'll get what is P clock and P clock G. Here, if you see in my RTL, I have two clocks, P clock and P clock G. One is a normal clock and one is gated clock. So according to this clock abbreviations, I have defined my SDC also with two clocks. I need to use the same naming, whatever it is there in the RTL. If not, the tool will not accept. Remember this point. Whatever names you have given in your RTL file, it is case sensitive. Again, you need to specify the same name in your SDC file also. Because I have two clocks in my RTL, I need to specify each and every constraint and each and every delay value with respect to two clocks. That's the reason I have defined all the inputs delays and output delays with respect to two clocks. So if your RTL is having only one clock, that means you can just give only one clock. It's your wish. Okay, how you set input transition? It's again the percentage of clock period. So here I just took some 0.8 or 0.9% of clock period. So it's the same way, there will be some percentages given by the time budgeting team. You need to give some 8% or 0.9% according to your clock period. So as a first user, you can just write off with 0.1 and 0.2 if you're taking some frequency or timing period as 4 nanoseconds. So this is again taken SDC file with the practice itself. So as a first user, you can just set off some random values and see the report analysis. Okay. So setup and hold time are taken from the libraries itself. So once the timing report is generated, I can show you how the setup and hold time is there. So more any queries regarding this SDC file so that I can run that tickle file and show you the results. Okay, Amrita, I am again repeating the same thing. Like it's some percentage. We just randomly took some percentage according to the clock period. Like we got some specification file for this particular design that your clock period should be this, and your input and output delay should be this much percentage of your clock period, and your transition is this, and your load is this much percentage of your clock period. So that's the reason we have took that values. Okay, so Maithili, do you remember the previous session I have explained about this library file? So there are some table values, lookup table values, where we take some index 1 as input transition and index 2 as output load. So from that particular library file, the cell delay values are taken, not from SDC file.
Hi, ma'am. This is Maithili.
Yeah.
Actually, ma'am, in that library file, you said index 1, index 2. So index 1 represents the input transition and index 2 represents the load capacitance. It have a
Yes.
multiple values. Okay.
Yes.
But we have to select the particular transition and particular load. According to that, we have to calculate the cell delay in the
So
table
yeah,
format.
yeah. If you were in the previous session, yeah, just let me complete. I just told like there is an NLDM lookup table happening. So the
Hmm.
tool is automated in such way, whatever transition value is suitable for optimizing your timing, optimizing your power, and optimizing your area, that process is taken care by the tool. Which delay value it has to pick, it is done by an interpolation process. It's tool automated technique. As a user, you should not bother about such kind of things because it's tool automated. We are just giving input like you need to take in this particular range of values according to the library.
Okay.
Yeah.
Okay, thank you.
Yeah. Okay, let us move on then. So now I have told you to read SDC command. Now as sir discussed, report underscore timing hyphen lint will show the linting check. So it checks the linting errors. That means the RTL is having synthesizable constructs or not, and if my SDC file is having any errors. So what are the errors and all? Like I'll just show you once everything is run. Now the next are three steps of synthesis. So the three steps of synthesis are translation, mapping, and optimization. So translation is taken care by syn underscore generic, and mapping is taken care by syn underscore map, and optimization is taken care by syn underscore opt. So this is the file that we are going to run, and write HDL is to write out the output gate level netlist, and write SDC is the command to write out the output SDC of the input SDC whatever you have given. Okay. Now let me. Is it clear till here? Okay. Okay, one small question, like anyone have accessed or tried to run in the environment that they have allotted for you? At least one of you, like who have experienced that environment.
No, ma'am.
Okay. Okay. Now let us get into the process. Now I have a directory here in my design called synthesis. You can just also create separate directories and put RTL in the RTL directory and SDC in the SDC directory, so that it will be easier for you when you're opening and closing the files, when you're checking the results and all. So now here I have a file where I have dumped all the commands which I need for the execution of my synthesis. So here I am opening the terminal. Okay. Now, the first step is, I'm repeating it again so that you can get a clear idea. First, you need to enter into a command shell environment where you can execute the commands. So, I'm just maximizing. Yeah, is it visible? Okay. Now, first we need to enter into some command shell environment where you can execute the commands for invoking the tools. So, CSH is command shell. I'm just giving CSH. Now, you need to source the tools because you need to do the implementation in the tool, not in the terminal of the Linux. You need to invoke the tools. So, to invoke the tools, you need to invoke the file where all the tools are set. Now, where all my tools are there, set here is, I have a file called CSHRC in the home and cat directory. So, source home, inside home I have a directory called cad, and inside cad I have a directory called file called cshrc. So what is this cshrc? Let me show you so that the path varies also, you can just check it. So to open a file, I am giving an editor option. So gedit is one of the editor in the Linux environment. You can use any editor, but this gedit is basically user friendly as Windows. That's the reason I'm opening in this particular editor. So gedit is the command to open any file in your Linux environment. So gedit, I am giving the path, that is home. Inside home, I have a cat directory and I have a file called cshrc. Now, this file looks something like this, where all the tool environment related stuff is included in this file, so that once you source this file, all the tools will be setting into that particular invoking environment, and you can just give the name of the tool and you can just invoke the tool. So here you can see for the genus, the path is already set. So according to this, you need to source the CSHRC file. This is not so important, but I'm just telling you why we are invoking this particular CSHRC file. So once I have invoked that CSHRC, you can see I'll be in such kind of environment called as welcome to Cadence tool suite. Okay. So once you are into this, that means you can invoke the tool. So the tool we are using for the execution flow of synthesis is Genus. So I am just giving the command called Genus. So Genus is the command to invoke the Genus tool. Okay. Now, once you are inside the tool, that means you will be into some such kind of thing. So Genus at the root, or it might be some other user also. My username is root, but according to the environments allotted to you, the usernames might be different. Don't get confused. But you will be having an arrow. That means you are inside the tool. Okay, I'll address your question, Madhu. Uh, Now, I have all the commands in a file called run1.tickle. So the previous day I have showed you like how to execute each and every command directly, or in other way you can just source the file also. So here I am just sourcing the file where it will execute the complete steps of the synthesis which I have mentioned in the run.tickle. So to execute that process, the command is source run. The file name is run1.tickle. Okay, just give me. Just give me a moment. So I'm just entering into Genus. Okay. Now the command to run the run.tickle file is source. So I'm just giving source and the file name is run1.tickle. If you just press tab, it will show the list of files in that particular directory. So run1.tickle is my file name. I'm just running that file. So whatever steps you have mentioned in the run.tickle will be executed at a time. You can execute command by command also if you want to know the mistakes if you are new to this environment. Okay, so is there no GUI for this particular thing is one of the question. So the command for showing the GUI is you need to execute a command to get a GUI window here. So GUI underscore show is the command to open the GUI window. Okay, so this is the GUI window here, and here if you can see, you can just get the design name here and right click on it. You can use open in schematic viewer main or in schematic viewer new, and you can just see the gate level netlist that it has got created. So this is basically the GLN in the schematic form. If you can zoom and see, I think you're able to see the gates, some flip-flops and some AOI gates, NAND gates. Is it clear? So this is how you need to see the GUI. Okay. So once everything is done, so this command basically report timing lint. Most of you were asking the queries regarding this. So report timing hyphen lint basically shows the synthesizable constructs are there in your RTL or there are any issues with your SDC. So as of now, I don't have any issues. That's the reason it is showing 0. So let me tell you each and every point. So what is unconnected or logic driven clocks is there is some clock port in your RTL code. You have defined some clock port in the input sensitivity list of your RTL code. Now, you did not define any logic which is connected to that particular RTL code. I mean to say, but that input port, that is the clock port. You did not define any logic which is connected to that input port. In such kind of cases, you get an error called unconnected or logic driven clocks. Clear? With the Is it audible? Okay.
So,
Yeah.
ma'am, I have one doubt. Ma'am, actually, when we synthesize the RTL code, okay, and you showed window for a GUI, right?
Yeah.
So there, sometime we get unmapped or partially mapped. What is that actually?
So once optimized only, you can see the design is mapped. If it is partially mapped, that means there is some issue with your RTL code. Your RTL code is not proper. If you are having any issues in your RTL code, it shows such kind of things. It is not able to map properly, or it is not able to properly map because of the issues in the library file. Because library is the only component where it is doing that mapping operation, right? It is finding the cells in that particular library. So if any issue with your RTL and any issue with your library, it will show such kind of issues. So
Okay,
here,
but
because my design is completely mapped, you can see it is showing design is mapped.
yeah, right. But that's what sometime in labs we get that problem when we are
Huh.
executing programs in the lab. Okay,
Mm.
so there that time we get it is unmapped, but the lib files we cannot edit, right? That is
Uh,
given by the I mean N2PL only. So that's
okay.
why I don't know, like in RTL, what may be the problem? Like,
So the logic, whatever you have written, let me just take an example. You have written a logic where it has to pick a gate called 2 cross 1 and. So you need to
okay,
have a AND gate where it has to have two inputs and it has to have a one output. So 2
yeah,
cross 1
right.
is two inputs and two. Now in the library file, it is not having such kind of AND gate. It is having some AND gate which is of 2 cross 4 or 2 cross 6. So in such cases, you will get such kind of errors also. It might be an issue with the RTL, it might be an issue with the library. So that is where we can't define which exactly it is.
In that case, we need to change RTL code. You mean to say?
Yes, definitely.
Okay, thank you.
Yeah, yeah. Uh, okay. So next, let us move on to the next things in this particular lint summary. So sequential data pins are driven by a clock signal. So in the RTL code, you have written some RTL logic where your sequential clock pin, that means your clock pin is getting a data signals. It has to propagate with CK, that is, it has to propagate with some clock signal. Clock switching have to happen in, but according to your RTL, due to some mistake or it might be an issue with the RTL engineer also, he have written the RTL code in such a way like data D logic is going to the clock. So in such kind of cases, you get this error called sequential data pins driven by a clock signal. Now, sequential clock pins without a clock waveform. Now, there is a clock in your RTL code. That means you have a clock port in your RTL code, but in the SDC file, for your clock port, you did not give create clock command. So, in the SDC file, you did not create clock for that particular clock port. In such kind of cases, you will get this particular error. So, sequential clock pins without clock waveform, that is what is I have discussed. Sequential clock pins with multiple clock waveforms. Now in the RTL code, a clock pin, like there is some logic for the same sequential register or for in some of the always block, you have written two clocks parallelly, like posage clock or negate clock, or in some such kind of cases, this particular error will arise. So two clocks should not be going to a single flop. So that you need to make sure when you are writing an RTL code, or when an RTL designer is designing an RTL code. Next is generated clocks without clock wave. waveform. So this is where you have some divide by 2 logics in your RTL code, but you did not define any constraint for that divide by 2 logics in your SDC file. In such cases, you get such kind of errors. So you need to define the constraint if there is any divided by logics in your clock waveform. So generated clocks with incompatible. So these three are basically related. When it is not related to your top module clocks, and you have some issues with the clocks when you are writing this always loop, this particular errors will arise. And path constrained with different clocks. So this particularly is you have some path. As I told you, backend only bothers about synchronous designs. So here, the complete RTL code will be having a path, like as such, let us assume, it has to propagate only with one clock. The complete logic which is related is have to propagate with that particular logic, and it has to be synchronized. But the RTL designer have designed in such a way, like for a single path where it has combo logic connected in between, it is projecting two different clocks. So in such case, it becomes asynchronous, right? So if there are any asynchronous logics in your RTL code, such kind of errors will arise, path constrained with different clocks. So loop breaking combinational feedback loops. So here in the RTL code, there is some logic written where a combinational feedback is there. That means your output is a combination feedback going for an input. So this is wrong. Such kind of RTL issues should not be there in your RTL code. As an RTL designer, you need to make sure you don't have this combinational feedback loops. So if that kind of issues are there, such kind of errors will come. Now, the other thing is nets with multiple drivers. So let us assume an example where I have an AND gate and I have a OR gate. Now, this output is singly, I mean to say it is dependently two outputs, but it is singly going for a buffer. So now this buffer will be getting confused. Which is the input I need to take? I need to take this AND gate output, or I need to take this OR gate output. So this particular input of this buffer cell will be getting confused which output I should take. In such cases, you will get an error called net with multiple drivers. So here basically the input net of this particular buffer is handling multiple inputs. So that is again an RTL issue. If you are finding this issue, you need to report to the RTL designer if you are working in this real time. So timing exceptions with no effect. So this part is again related to the SDC file. So there will be some paths in your gate level netlist that you don't have to realize timing for that. So there will be some paths, some logic in your gate level netlist that you need not bother about timing for that particular logic. In such cases, you need to define some exceptions. So if you're not defining that exceptions, if needed for that particular logic, in such cases, you get an issue called as timing exceptions with no effect. So these are nothing but the paths you need to mention where you should not bother.
But the paths you need to mention where you should not bother. The paths you need to mention where you should not
Okay. Next is multi-cycle exceptions. Now, there is a flop in your RTL code. The data transfer is happening from this particular flop. Now, this flop is taking multiple cycles of clock to propagate the data from this sequential cell. So I have a clock here. Now, within this, when this clock is edge triggered, I need to transfer the data. But for some sequential cells, a single clock is not able to transfer the data. Now, in this case, I need to give a constraint called as multiple cycle exceptions for that particular sequential cell, so that I am telling the tool that you need to give multiple clocks for that particular sequential cell because my data transfer is not happening in one single cycle. So this again is related to the SDC file itself. So from here on, the timing exceptions, it is again related to SDC file. So pins and ports with conflicting case constraints. So in the RTL file, if there is any case statement and you are not defining conditions for some of the input and output logic, because obviously case statement is you are giving conditions when your port objects are triggering and with some conditions like 0, 1, 2, and 3. So if you're not mentioning any case constants in your RTL code, such kind of errors will arise. So here, if you're not inputs without clock external delays. So here, if you're not mentioning input delay, you are in your SDC file, you get such kind of error. And if you're not mentioning any output delay in your RTL file, I mean to say in your SDC file, you'll get this error. And inputs without transition. So if you're not mentioning transition command in your SDC file, you'll get this error. And if you are not mentioning your load value in your SDC file, you'll get this error. So exceptions with invalid timing and starting endpoints. Here, I told you like timing exceptions with no effect. That means there are some paths where you should not realize timing. So you need to define that timing exceptions, right? Now, in the SDC file, you have defined that timing exceptions, like these are my timing exceptions, but you have defined that timing exceptions wrongly. That means you have defined it in a wrong starting point and a wrong ending point. It might be a syntax issue, or it might be a wrong point to point analysis of that particular logic. So in such kind of error, you will get this particular exceptions with invalid timing start and end points. So as a starting user, I think you guys might be just picking a logic of a counter or not. So this all exceptions is not so required for you. But when you take a complex design, like when a complete integrated circuit will come, this lint summary matters a lot because it is giving a usage of SDC file, and it is giving me the usage of the RTL file also. So it is compatible both for an RTL design engineer and a STA engineer or a PD engineer to go to the further process of implementation. So I think it is clear. The lint summary is clear. Okay, any questions regarding the implementation so that we can start off with the next? Okay, what is there in output SDC? Yeah, I'll discuss that. Till here, till lint summary, are there any queries? Okay, let us move forward then. So now here, once the complete process is done, that means you have done 3 steps of implementation, that is translation, mapping, and optimization. You need to generate some reports to move forward for this STA analysis or to move forward with the physical design analysis. Now, what are those reports? So the outputs of my synthesis is gate level netlist. So the command to generate gate level netlist is write underscore HDL. So write HDL will give you the optimized gate level netlist. That means output optimized gate level netlist, the finalized gate level netlist you will be getting. Now, if you want to save this file, I told you previously also, write underscore HDL is the command. And if you want to save this file, so write HDL and you need to dump in that particular file with a arrow symbol, that is greater than symbol, and you can just give the gate level netlist file name. So the gate level netlist file extension will be same as the RTL file, whatever you have taken as input. So my input RTL file is with an extension of .v. So I am dumping the optimized gate level netlist also with an extension of .v. So I'm just giving gln.v. Okay, now whatever write HDL is doing, it will be dumped in gln.v. Now the other output I need to generate to move on for the further implementation is SDC file write underscore SDC, and I'm dumping it in a file called SDC output SDC, and the extension of an SDC file is .sdc. So whatever is write SDC is getting executed will be dumped in that particular files. Now let us open that file and see what is that is there. So I am just opening the SDC file first. So gedit, my SDC file is the output SDC file. Okay. Is it in sync with the voice and screen, because I am able to see this comment? Or please check your network connectivity, because from my side I think it's fine. Okay. Now in the input SDC file, if you can see, okay, in the input SDC file, if you can see, I just gave the input and outputs. I did not mention the name of input and output. I just gave my clock port as this, and my input and output ports are this. But in your output SDC file, this respective delay values will be assigned elaboratively to each and every input port and output port. So this only one clock port is there. I'll get on to that. Just give me a moment. Okay. Now, if you can see in the input SDC file, I just mentioned all inputs and all outputs. I did not elaboratively give which input and which output of my RTL file. So this is my RTL file. So these are my set of inputs and outputs which I have in my RTL file. Now, what output SDC assigns is whatever value I have given in the input SDC, that particular value is assigned for each and every input and output port in my RTL. Because this is an array, because I have mentioned this as an array in my RTL file. So it is 31 down to 0 and 3 down to 0. In the same way, for each and every array value of the input, whatever value I have mentioned in the input SDC, the same value will be mentioned for each and every input and output in a elaborative way. So what is set don't use is while optimization of synthesis, some of the gates it is not using from the library. These particular cells it is not using for this optimization process. So it is mentioning that particular cells from that particular library as set don't use. It is just telling us the thing, right? Set don't use is basically we are not using that particular library cells while doing the process of conversion of gate level netlist. So again, this is the tool, whatever set don't use is the list of cells is coming from the tool itself. Manually, you should not give, because while optimization, it is not giving that, it is not picking or it is not touching that gates. The tool has mentioned that gates as set don't use. Okay. Now let us get back to the reports. So this is how you generate this gate level netlist and the SDC file. Okay. So once this is done, we need to check some reports also. So what are those reports? That is timing, power, and area. Now, what is the command to check timing? Report underscore timing is a command to check the timing report. Okay, I'm executing it again. So if you can see here, it is showing some timing report. My clock edge is nothing but my clock period, and my input and output delay is 33. That's the reason output delay is 33. So there we have given it as a nanosecond, but in Genus tool, the timing report is reported or projected in the form of picoseconds. So 33 nanoseconds is nothing but 33 like, yeah, 33,000 picoseconds. And in the same way, this timing report is calculated. And here you can see my slack is positive. So what is slack and all, I'll be telling in the STA sessions. But as of now, you can just see whatever numbers we have projected in the SDC file that are taken into consideration while calculating the timing. So I can make sure if my slack is positive or 0, that means it is a suitable delay value for that input port or output port. So this is how we get to an analysis how 33 value is suitable, or how that 83 value is suitable, and all. So if my slack is positive or if my slack is a 0 value, then whatever things, I mean to say, whatever values you have mentioned in your SGC file are suitable for the execution of this process. So I think, is it clear, like how we are getting to know it is a perfect value?
Get the slack positive. So what I
Is there any query? I can hear some sound, or you can just put it in a chat box. Please mute it from your
Hello?
side. Yeah,
Hello.
yeah.
Ma'am, actually you said like the whatever the delay we are calculating, it is just for in a clock. How it is?
Yes, see here I'm just showing for the clock itself, right? So here my start point is some input port or some output port. It's an address port, and my end point is some other port. So here you can see between this ports I have this much of logic. So this logic delay I am not giving. It is taking by automatically from the library itself. What is the value I am giving is the port delay values, that those are nothing but this 83 and this 33 values. So these delay values which are of my gates, it will be picking from the library itself. Okay.
Hello.
Yeah.
Hello, ma'am.
Yeah.
Ma'am, actually I want to know like what is the total delay of the circuit?
Total delay will be your maximum frequency, right? The frequency at which whatever you're operating will be the complete delay. That's the reason total delay at a time you can't segregate. You need to define the paths first. So segregating by paths itself, you can make it out a complete delay. But as a starting user, you need to define the frequency as itself the complete delay.
The more about the timing we will discuss in the STA sessions. Almost 1 week we have completely dedicated for static timing analysis. So
Okay.
all the path delays, everything, we'll explain in detail. So the
Okay.
synthesis part, any questions still we can address and then move forward.
Okay.
Okay, sir.
Yeah. Okay, and now the other report, once we have generated the timing report, is report power. So you can just give the report underscore power for checking the report of the power. So here it will show the total number of cells in your design, and for the total number of cells, what is your leakage power and what is your switching power. That is nothing but your dynamic power for the complete circuit. Now how will you finalize this is your final value? There will be a report of in the form of CPF. There they will tell if the power is this much value, you can take it forward, or else you just have to optimize your circuit, do some RTL modifications or do some SDC modifications from your side, so you can achieve that particular value whatever they have given to us. So while you guys are practicing, just do this report underscore power and check the power value before optimization and after optimization, so that you can just see the difference how it is optimizing. Now once this report power is done, you can just do other command for report underscore gates, that is report gates will show the gate count. Okay, this is your gate count and total number of sequential cells, inverters, buffers and logic are nothing but the logical cells. That means the combo logic cells and or gate cells, and physical cells, because you do not do any physical synthesis, it is showing as 0. So when you get into that physical synthesis part, you can see that physical cells. As of now, we are just doing logical synthesis. That is the reason it is showing 0. And the area occupied will also be 0. Because you are not doing any physical implementation. That means you did not dump that gate in a particular area and you did not give the width and spacing values of that particular gate. So here it is, the area unit is micron meters. So this is how you need to generate the reports. Now, as a starting user, you might not be knowing what the command is doing. So listen carefully. This command is very important. So there is a command called man of any of the command. Man is basically a man page of the commands whatever you are executing. So man and the command, if you want, I just want the description what report underscore timing is doing. So I am just giving man space report underscore timing. Okay. Now it will show me the description of the report timing command. So while doing report underscore timing, what is that it is executing? So I am just giving man and man space report underscore timing. So this command is basically doing the analysis. If you can see, okay, I list man and man on report power because it's, you can do on report timing also, because the window is small, it is not able to display the complete thing. You can dump it in a file and see also. So I'm just showing man on report power. Yeah, so you can see the description of that particular command. So reports the power consumed. The information written depends upon the current position in the design or hierarchy. So you can know the description of each and every command just by giving man and the command. So the syntax of executing that flow is man and the command name. So man space report underscore power will give the description of report underscore power command. Okay, so here this is how you need to do the descriptions of each and every command. If you are a starting user, you can go check out the description of each and every command. Okay, so is there any doubts with this explanation, or shall we move on for the next part of synthesis?
Hello, ma'am.
Yeah.
Ma'am, actually, you calculated power and area with the command report underscore power and report underscore area, right?
Report
Actually,
underscore gets. Hello? Hello?
when we go for the GUI, there also we have a what is that icons like a power area, right? So
Yes,
from there also,
obviously
there
you'll
also.
yeah, you will get the same results itself, but in industry wise, we'll be used to
Hello.
using the commands. Hello? So usually in industry, we go by a command approach. So that's the reason I'm just showing you the commands. If you are new to this, like I'm just showing the command flow, you can just check it in the GUI also, no issues. Okay, if we are done with this, I'll move on to the next synthesis stage so that we'll get back to the flow. Is it clear? So shall we start off with next type of synthesis? Okay. So I'll address the remaining questions once I complete the physical synthesis part. So two types of synthesis. One is logical synthesis and the other is physical synthesis. Now, till now, whatever we have executed is logical synthesis. That means we are not giving any physical information as an input. We are just giving some RTL file, we are giving some SDC file, and we are giving the library file for the implementation. But if you take in real time, there will be no 100 number of gates, there will be more millions of gates and trillions of gates. So in such cases it will be very difficult to finalize the optimized gate level net list only doing the synthesis with the help of logical synthesis. So that is very difficult when you have a logic depth of more and you have more number of gates. So logic synthesis is not suitable in such kind of cases. Now, there is an other approach to do that implementation of when there are more number of gates. So that is nothing but physical synthesis. So let us start off with physical synthesis. Now, due to the accuracy or wire load models lead to the poor correlation between synthesis and post layout in nanometer technologies. So here what happens when there is a complete integrated circuit implementation happening, or when you take a larger circuit, is whatever estimation results that you are getting in the Genus implementation of logical synthesis is not suitable. That means it is not suitable, the results are varying very far when you actually implement in a layout. So that's the reason they come to this physical synthesis part. So instead, we use a physical information during physical synthesis. So here, what are we doing is physical synthesis is a flow makes use of its knowledge of physical layout and timing target given to a design in order to achieve minimum area usage at a required speed. Okay, let me complete. I see the questions are arising. I understand, but let me complete the complete thing first so that I can explain it elaboratively. Now, I have a design. I have a circuit here. Now, in the Genus tool, that means while I am doing synthesis, it has estimated the gate is sitting here and some combo logic is sitting here, and to the combo logic and another flip-flop is attached. So this was my logic synthesis approach of gate placement in the tool. But when you went to physical design, whatever implementation of the approach, whatever they have done that got failed, that means your gate sequential cell is sitting somewhere here and your combo logic is connected with some more wire delay and your flop is connected with more wire delay. So this was the drawback of logical synthesis. It was not able to estimate the wire delays when it is going to physical layout. So that is why it is mentioned here as it is the poor correlation between the synthesis and post layout when you go to the nanometer technologies. So that's the reason we give some information to the tool informing this is my core area where you need to implement so that your area will be minimized. So that is the reason here I mentioned synthesis is done by giving extra inputs which is generated by physical design tool in the floor plan stage. So here the inputs include the RTL design, the SDC file, library models, and the extra input we are giving here is the floor plan def and the physical library file, that is the library exchange format file. So now, once this information of the physical guidance is given to the tool, so what are we achieving is it achieves the better correlation between the synthesis and physical design. So it is giving the layout as estimated in the genus stage itself. So here this particular physical synthesis is called topographical mode when you take the synopsis constraint, and in Cadence it is called as physical synthesis or two-pass synthesis. So what are the inputs again I'm mentioning here? So the extra inputs we are giving is the left file, that is the library exchange format file, and the floor plan def file, and the netlist, that is same for the synthesis netlist. And these are all the libraries we have given previously for the logical synthesis, and SDC file also will be same as we are performing for the synthesis. I will tell what is def left in a descriptive way. Let me complete. Okay, so these are the list of inputs and outputs.
So one kind request, to some of you who are very sharp, active, and very curious and enthusiastic people, I request, humble request, is to wait for the explanation before you, trigger your questions. I feel, the content what we have put, 90% of it will answer all the questions once we finish the session. Maybe 10% we will take one by one. My kind, and humble, because to keep up our time. And the moment one topic comes, I see that what is def, what is left. All this information we are putting, that is where we are coming here to explain, and even the reporting, everything, right? We will answer all the question, the nth question, right? Till by the time we finish all the sessions, we will address it. Okay, and that's one thing. Second thing is, some of you are already trying it out, and then suddenly what problem you are facing, you will put, that is very good actually. So those also we will address. Okay, and please tune to what Shravanti is doing. So definitely all your questions will be answered. Okay.
Yeah. So these are the list of inputs. So the Verilog code, that is the RTL code. Next is the library file, that is the .lib file. Same we have used for the logical synthesis. Constraints also, the input SDC file, that means where we are mentioning collaboratively like all inputs and all outputs. So the same input file itself we are going to take. Def is a new input, so I'll be telling you guys what is def and what is left. And there will be some designs, like say there will be some application integrated circuits where your circuit will be some power constraint. So for not for all the circuits, only for some of the circuits where power matters a lot. So in such kind of applications, you need to give some power input files also, like CPF, that is Cadence Power Format File. Safe is switching activity information file. These are all the same files but for different tools. So TCF is toggle count. VCD is variable change format. So collaboratively, if I can tell what is the inside content of this power optional file is, it will have the switching information. Basically, when you do verification, you get a simulation waveform. So according to that switching information, you can get to know the estimation power analysis of a logic circuit or the netlist file. So with the help of this file, if you give that particular file as an input while doing physical analysis, that will be easier for the tool to do the power implementation or to optimize the power results. So that is why if the tool is demanding an application of the power perspective, in such cases you can use this optional files as CPF and safe or toggle information file.
Shravanti, just let me
Yeah.
add one point here. See, especially when it comes to the power, right? In the ASIC flow, we discussed the main three important things what we will be chasing are the PPA, power performance area. So power, right from RTL coding level, we try to optimize circuits for power. That's what some of you are asking about gated clock, P clock G, right? So we also answered that clock we don't want to run all the time, or there will be free running clock, but to the circuit, right? I want to provide to a particular block only when that block is needed, when it needs the clock, right? So what I am trying to do, I am reducing the switching there, reducing the switching of that flip-flop. Okay, so in the last session, we also explained about this. So that is one of the low power technique. Okay, clock gating is one of the low power technique which we are including right from when you are writing the Verilog code. Okay, so now here, once you synthesize, okay, once you synthesize the logic synthesis you do, you get the netlist. Now the tools, power estimation tools, right? Already you're seeing the Genus also will report power. Okay, will report power on what basis, right? Depending on the switching activity. So what it reports right now is the static power, but because it will not be having any information about the switching activity, right? The more accurate or closer to approximate or closer to the realistic power, what the device would consume will be based on the activity, right? So for example, now it is budgeting versus real, right? You estimate something, right? It is going to cost, now you are planning a trip, it's going to cost some 10,000 rupees, and then actually when you go and then finish the trip, it would have been, maybe your accuracy level of budgeting depends on, so maybe 12,000. So the 2,000 is the only difference, right? So that way budgeting, right from here synthesis time, we start doing it. We estimate the power. Now on what? Now switching. What is switching, right? The power is consumed mainly because of switching, right? Now where the switching activity or switching information you can get from, when you simulate. Here is, this is synthesis process, RTL code, applying my test vectors, I simulate, I subject this RTL code to the maximum functionality, right? Maximum functionality means you have written this for one data transfer, complete data transfer test case you write, and then when the transfer is happening, you capture the activity using one way is normal simulation is VCD here. So value change temp, actually it is value change temp. So whatever waveform, every clock is switching, input is switching, output is switching, the maximum switching when it is happening in the design, you capture in the VCD. Now that VCD file you provide to this tool in order to estimate the more realistic power. Okay, so similarly toggle count format, this is also one way. Again, it talks about the switching, right? How many signals are toggling, how how often, right? And save file, Especially there is also switching activity information format, which will be created when you are simulating. And CPF, like Shravanti told, cadence power format, and one more comes actually, that is UPF. So always there is always a war between these EDA companies, right? I am great, I am great. So like every individual. So cadence still is sticking to my format. Is they have come up with their own format of defining the for example, now in order to consume power, in order to conserve power, right, low power technique, right, so it will have certain guidelines, actually guidelines in order to explain the low power. There are different modes, for example, standby mode, active power mode, standby mode, right? There are some the sleep mode. There will be multiple modes a particular device has to work on. Those modes, right, low power, the power down, power on, information will be provided by CPF. Similarly, UPF is coming from synopsis, that is universal power format, right? So these are all given to the synthesis tool in order to get, let us say, previous thing what we discussed, logic synthesis, right? Now we just considered only the library constraints and the Verilog code. Here, physical synthesis, like Shravanti explained, now the physical information is coming from left. Def is design exchange format, which is coming from after place and route, which is more realistic, including the wire delays and all. And at times, instead of, in addition to the RTL code, some blocks are already available in the netlist form. Those are also given. Now, with all these additional information plus the switching activity, now you're in a better position to estimate the power, right, which the circuit is consuming. Okay, so that is where this if you are focusing on power analysis, you will provide all these inputs. That's where it is mentioned as optional power input files for any design. So hope I am clear. See, the low power is a way of doing things when you are designing ASIC. So who doesn't want low power techniques, right, to be embedded in the device? Okay, so that is where the logic synthesis versus physical synthesis. That's where I asked some of you to park your questions on the physical synthesis, because we were about to explain all these things in detail. Okay, any questions around it? So this is the physical synthesis. And then now at times when people talk about physical synthesis, it is about physical design process, because the def file, the design exchange format file, is an output which is coming after placement, your floor plan placement, and the route. After routing, this file is coming. Okay, so that way we it is often said physical synthesis means it's backend flow. Okay, so that also, if you're having any confusion about it, so that's a way to tell, because this is coming from the output of backend process. So you are including here in order to get all. See, again, the def phase need not be for all the blocks. Only for some blocks you may get def, for some blocks you may get left, for some blocks you may get netlist, for some blocks you may get RTL. So that way it is a conglomeration of the combination of all the things, and then all the inputs will be given, right, and then taken to the physical synthesis process. See, these are all ways of doing this depending on what stage you are in. For example, when you are using spyglass flow with the netlist, now you generate a safe. Okay, now any, for example, model sim or any kind of Questa sim, when you're using, just you generate the VCD, because any simulation the standard format is VCD. Okay, so yeah, def and left, there are multiple slides coming up for you. Shravanti will explain, just hold on. So there will be a lot of explanation which will be given about left, def, and library. Anyway, you have learned. Okay. So Shravanti, one thing, just I want to check. Avinash, are you there? Anybody from NTUPL? I just wanted you to take them through another 15 minutes.
Yes, sir. I am there, sir.
Avinash?
Yeah. Hello. Srinivas. I am there, sir.
Okay, Srinivas. Okay.
Yeah.
So, Shravanti, will just with this introduction, we will pause today. Just we have given introduction about physical synthesis, and then tomorrow we will further go on and explain and also demonstrate the physical synthesis process. Okay.
Yes,
And
sir.
yes, Srinivas, you can walk through the team. I think some of them had questions on the slot booking and getting access to the tools and other things.
Avinash. I have logged in as Avinash. Here you can see it is loading the tool steps. Had I given some steps along with my Genus command, it would have taken. Else, I can type the commands as Shravanti is explaining from the Genus terminal. It is taking some time, but after that, we will get that turned on.
So the minimum requirements, I think, in the earlier session, Damodar also has mentioned, minimum requirements is 64-bit machine, and minimum RAM, at least 8 GB is always good. It is better. Your RAM, if it is 4 GB, still it would work. Maybe performance will be little less. And in terms of the hard disk space for the usage, at least 10 GB available, right? And that is the config, and especially internet bandwidth, minimum 10 Mbps. Really, it will get a good response, right? So that is there's a couple of things. Avinash, you can add if any other.
Yeah, that's what. As you can notice, that it took some time for me. Had I have a good internet width, I could have gotten this terminal quite early. So please be patient. If your bandwidth is a little weak, it will come. So don't get panicked. So here you can type the command. Similarly, for Innovus tool, we can simply type Innovus. The only change, which is like in this case, you don't need to source those all files, CSH and CSHR file. You won't require to source. You can directly type the command to invoke the tool.
Let us not too much, right? 2 hours per day, right? So I think 20 hours lab time is available for you. Okay, so don't be skeptical about, start using it, right? Most of the time you'll get lost in the initial questions only. Start using it, and then 20 hours, what you could achieve, you produce some results, right? And this also, I think most of you, as I hear, 95% of you are Cadence users. So you will not be living in this for long. Just definitely after a month or two, you'll all be returned to college, right? So definitely in your college, you can access these tools as well, right? So that way you look at. Let us not be too much skeptical about whether 2 hours is not sufficient, 1 hour is not sufficient. Let us get started, load it. Later we will see whether you are, whether you are breaking that 20 hours this thing, right? Yes, Siddhant.
Yes. Here you can see the Innovus terminal is there, and below that, I can see as an extra tab that GUI is also open at my bottom.
So this is the view for physical design. Innovus we use from Cadence for physical design. I think those who have registered for the physical design training, you will be working with this environment.
Yeah.
So with all the tools, like we demonstrated the logic synthesis, physical synthesis also we will demonstrate with one example. And some of you already have Verilog code. You can take the Verilog code and then create. I think I am getting a question. So Avinash, if they have Verilog code, how they can take it to this environment?
Yeah, that's what.
Yes.
Like you can just show them the GUI usage of this particular terminal. You're just showing me the terminal, right? So you can just show me the directory structure about the terminal.
No. Shravanti, that is not the one what I'm asking. For example, I have Verilog code. Now this Linux environment logging in is all fine. Should I have to create everything only here? If I have something I can borrow here, if I have a design for SynthesTA and PD, I have my own design. Can I do that?
Ideally, sir, you can copy through the terminal.
From for example, all of them will log in from Windows machine. in Windows machine in one folder they have Verilog file. Now how do they copy? Can you just show one example? Copy one file from your Windows to this environment. I think that will set for them.
That I need to check it once. Maybe I will go through and then on some other day I can introduce that. Is that okay?
No. Just from your Windows machine, in desktop there is one file. Okay. Now
Yeah.
copy to this
I got-
Linux
I got
environment where you are working.
I'm yet to
Okay.
test that. I'm
Is
yet to
it?
test
Okay.
that. Yeah. So I will
Okay,
get on.
team,
I will work
so
on that
for
and I
your
will update.
information. Sure. Now this you explore because some of them may be having one, to try it out, and they can borrow their design and then try it out. Because in test PD they will not create Verilog code themselves,
Yes.
so they will
need to copy.
took it from there.
Yeah.
So can you show this in Linux environment? See, how many of you are using Linux environment? Tell me. How many of you are showing, using me? Okay. So some.
Okay. So we have good number of users who are using Linux.
Yes. There
Yeah.
are a couple of them. So
Okay.
I think we are done with Windows, right? This is how
Yeah.
the environment you go and then work on it. Okay, go to Linux and then quickly we can show all those who are looking for Linux. You can just watch out, Avinash.
Yeah. So for Linux, I have video as I am working in a Windows platform.